Hi, today we're going to be talking about parent functions and some of the transformations that we have. So we've talked about relations and other kinds of functions, and we've graphed some of these parent functions, but we're going to identify and give them names. And then we're going to talk a little bit about their transformations as we go through. But the main section is making sure that we understand what a parent function is and what it looks like. The transformations, we'll spend a lot of time second semester on that. So we're just kind of introducing it here. We'll come back to it though. So here's our parent functions. There's four of them here. We have the constant function, which is just a horizontal line, like y equals 1. Notice there's no x there. There's 0 x's. So it's y equals 1 or y equals 5 or whatever. So a line going through at any given point. Then there's the identity function. Also, I prefer to call it the linear function. But either way, it does have an x. Now, this could be any type. It could be 2x plus 3, or negative 4x minus 5, or 2/3 x. But notice it only has just that one x. And that line is a straight line. It's called a linear line. But it can be up and down. We can move it up and down, left or right, and we can go ahead and make it more steep or less steep. Absolute value, we've graphed a couple of these. That's the V-shaped graphs, okay? Those have that absolute value symbol in there, and so those are the V-shaped graphs. And then we have quadratic functions. And those quadratic functions are here. They're U-shaped graphs. And notice with the quadratics, they have an x squared. Now, some of them might have x's also. It could be like x squared plus 4x plus 3. But the fact that it has an x squared makes it a U-shaped graph. Now, what kind of transformations can we do? Well, if we add to our x, we can move it left, and if we subtract from our x, we can move it right. Notice those are backwards. You would think a plus would actually move it right, and a minus would actually move it left, but they are backwards. Now, if we're doing something outside the graph, outside the parentheses, or outside the absolute value, or outside the x squared, then we're just moving it up or down. If we're putting a negative in front, then we're reflecting on the x-axis. If we put a negative inside the parentheses, then we reflect it on the y-axis. And then we're talking about what we're multiplying by. We can go ahead and stretch it or compress it, expand or compress, depending upon the different types. Again, this is just a basic overview of this. This is the main topic for second semester this year. We'll build up the first semester to what's called the fundamental property of algebra, but second semester is really about transformations of functions. And we'll talk about a lot of new functions besides the four that we have here. All right, so let's take a look at this one. So here's our first function. And the question is, what type of graph is this? This is obviously a V shape. And so since it's a V shape, this is an absolute value function. Now notice it's translated 4 to the left. Now how would we translate it 4 to the left? Translate to the left, we'd have something like this. X plus 4 would have done that. So if we had the absolute value, y equals absolute value of x plus 4, that's actually what this graph is. And you can actually, by knowing its parent graph and how to translate it, I'm sorry, 4, that's only 3. It should only be 3, sorry. What about this one? This one's a U-shaped. This is a U-shape, so if it's a U-shape, it's a parabola. That's a special name for it, so it's a quadratic. So that's that x squared. Now we moved it 2 to the right from the origin that went over 2. So you could claim it as y equals x plus 2 squared, or x minus 2 because it's the opposite way. What type is this one? Straight line, no variance in slope, so it's straight across. This is what you would call a constant function. This one has a slope on it. So if it has a slope, it's got to also have an x. So again, they call it the identity variation. I call it the linear function. Either one is fine. Here, we have an x plus 1 squared. So you want to type that in your calculator or into Desmos and see what that graph looks like. Now, on our graph here, that's the original one in blue. Y equals x squared. That's what's called the parent graph. So what happens when I graph it? I get this green one. So it should act exactly like this blue one, but notice that plus 1 in there moved it over 1. And that's the translation. What's the translation? It's moved over to the left 1. Okay, so the basic one goes to the origin, and you're just kind of looking to see where it got moved to. All right, let's try another one. You can go ahead and type this one in into your calculator, and the blue again is the original, and the new one is here. So if it's over 4, we've moved it 4 to the right. Now looking at this one, notice what happens with the negative in front. The negative in front makes it go upside down. It reflects. It reflects across the x-axis. So that's what we're just kind of doing today. You're going to graph this one, y equals negative x squared. Take a look at it. The original one's here, and the second one is here, so it's again reflected. That negative reflects. How about putting a half in there? That's going to be our compression or expansion. Sorry. So this one, instead of being the blue one right here, it ends up being a little bit shallow, more shallow of a slope, a little less steep than what it was before. So that number in front is going to do that, going to expand or spread out, make it go up slower. So here's a 2x in here, and it's the same thing. It kind of makes it go up a little bit slower. All right, here's one, a lot of different things, but notice it still has an x squared. If it has an x squared, it's going to be a quadratic. Now let's take a look at how it looks on a graph. Here's your blue graph, and here's the other one. So what happened to it? Well, it got flipped, so it got reflected, and then it went over 2 and up 1, or 2.5 actually. Oh, this goes by 2. They changed the axes on here. So this is over 5, and then up 2, 4, 6, 8, 10, 12, 12.5. So it goes ahead and changes it. But you can see those numbers here. We have the 5 and the 12.5. That's where you know where these numbers kind of come from. But looking at the graph, you should be able to tell, oh yeah, it's flipped, and we translated it over, oh yeah, 5 and up 12.5. So what about this one? The negative is going to flip it. It's an absolute value, so it's a V-shaped, but it's going to be flipped. It's going to be over 4 and down 2. So here's that graph. It gets flipped. It's over 4 and down 2, and that 1/4 spreads it out even more. So that's what this one ended up being. Which one's not accurate? It did not go 4 to the right. It went 4 to the left. But you can go ahead and look at that on your graph. And that's what I have for you today.